Hello, everyone, and thanks for tuning into this special webinar for Partners of Scott County Watersheds. My name is Cassie Drewell, and I am the coordinator. For those of you who aren't familiar with Partners of Scott County Watersheds, we are a local nonprofit located in Scott County. Our mission is to improve the stewardship of Scott County watersheds through education, technical guidance, and volunteer opportunities. One of the ways we do that is our monthly educational forums. We also do snapshot volunteer water quality monitoring and special workshops like this one, in addition to other fun activities. So go to our website to learn more. My internet's being slow. Well, just for the sake of time, I will mention that we do have membership and partnership programs available. That's how we continue our mission. We have several great partners who fund us: the City of Davenport, City of Eldridge, Hawk, and also Continental Cement and Iowa Corn, and a couple of private donors. So we really appreciate them. I would ask everyone to stay muted during this presentation. However, if you'd like to ask any questions, you can type them in the chat and I will forward them to Jake as he goes through the presentation. This email will also be recorded, so you can view it later on Partners of Scott County Watersheds YouTube. There's also going to be information about CCA credits that Jake is going to present at the end, and I will also email that information to everyone after the presentation. So I will go ahead and stop sharing since my computer's frozen, and I will let Jake take over. So thank you. You're muted.
Oh, yep, I'm unmuted. Can you hear me?
Yep, thank you.
Okay. So today we're going to have a discussion about agronomic management factors for preserving water quality in corn-soybean cropping systems in the U.S. Midwest. So I know I get really specific with that title, but we're going to get specific. So we're going to focus in on what agronomic management factors are important for protecting water quality specific to corn-soybean rotations, which is extremely common in Scott County. So it applies extremely well to Scott County. Before we get into the nuts and bolts of the presentation though today, my slides are not advancing. Oh, now they are. Okay, before we get into the nuts and bolts of the presentation today, I'm gonna share just a little bit about myself so you all can get a little bit more comfortable with me. So I grew up on a farm in Missouri, just north of St. Louis, corn, soybean. Grandpa had some hogs and cattle, but I was most interested in the corn and soybean crops, I suppose. So I went to school at Northwest Missouri State to get a degree in agricultural sciences. I also happened to play football there. I was an offensive lineman at Northwest Missouri State, and this is much less impactful since you can't see me, but in that picture there, I weighed about 289 pounds, and today I weigh about 189 pounds. so I'm quite a different fella today than I was back in my football playing days. So after I finished up at Northwest Missouri State, I moved to Oklahoma for a couple of years, and I pursued a master's degree down there in the plant and soil sciences. We conducted field research all over the states of Kansas and Oklahoma, and I learned so much in that experience in a different cropping environment. Yes, they have corn and soybean in Oklahoma, but they have sunflower, hard red winter wheat, grain sorghum, peanuts, cotton, much more diverse cropping system in Oklahoma, especially Western Oklahoma, than back home in Missouri where I grew up. After that, I went to work for DuPont Pioneer as a research agronomist for them in Eastern Illinois. Decided that I was going to go back to school for some crazy reason. I had to talk my wife into it, and there's a picture of my wife and I when I graduated with my PhD. I got a PhD there in crop sciences at the University of Illinois, and today we live in Davenport, Iowa. That's my wife and our youngest little girl, Lillian. So we moved here to Davenport, Iowa, and I went to work for Twin State Incorporated. Twin State Incorporated is the company that owns Rock River Grain and Lumber and the Liqui-Grow ag retail facilities in Eastern Iowa, Northwest Illinois, and Southern Wisconsin. So what do I do for Twin State Liqui-Grow? I manage our research and development department. I provide a lot of sales support to our customers at meetings and one-on-one visits with key accounts. I lead agronomic trainings for our sales force as well as our customers. And I get involved in agronomic service calls. So in other words, if a customer of ours has a significant problem, I would be called out to help all parties understand what may have happened and what we can do to fix it, or what we can learn for next year. So we're going to move on here if there's no questions about me, and we're going to talk a little bit about, why should we care about managing nutrients carefully to minimize environmental impacts? I know that we all generally understand why, but I think it's important that we set the stage a little bit here for why we should care about implementing these practices or adjusting our practices based on my recommendations. So why should we care about environmental stewardship and keeping clean waterways? Well, I think first and foremost, I'm not here to debate whether or not global warming is real. You are welcome to your own opinion of that. But if you do believe it's real, then you also believe that carbon dioxide and other greenhouse gases are contributing to the rise in temperatures that we've seen over the decades here. And one of the greenhouse gases that's actually a more potent greenhouse gas than carbon dioxide is actually nitrous oxide. And nitrous oxide is actually a byproduct of a process called denitrification. So when nitrogen fertilizer is applied to fields and it is exposed to saturated soil conditions, we have a compound that's released called nitrous oxide, and that's actually also a greenhouse gas. About 7% of the warming effect from greenhouse gases is contributed to nitrous oxide. 81% is from carbon dioxide, but about 7% alone of the global warming is caused by nitrous oxide. And about 78% of that nitrous oxide comes from agricultural soil management. In other words, nitrogen fertilizer management. So how we manage our nitrogen fertilizer has an impact on global warming. It really does. Not only is carbon dioxide produced when nitrogen fertilizer is made, but if we don't manage it appropriately in the field, it also contributes to global warming via nitrous oxide. So not only does managing nitrogen ineffectively increase global warming because of nitrous oxide emissions, but we also have something called the hypoxic zone or the dead zone in the Gulf of Mexico. So when the nitrate nitrogen runs off the soil surface or runs through the soil or runs out of tile lines and runs into the Mississippi River, that high nitrate concentration, when it hits the salty water in the Gulf of Mexico, it produces something called a hypoxic zone or a dead zone. What happens is we have algal blooms because phytoplankton nitrogen is often limiting in salt water. a limiting nutrient for those phytoplankton in salt water, and they explode into a green bloom. And then what happens when those bacteria, when those algae die, during their decomposition process, they suck up all the oxygen in the water, which fish and other sea animals need to survive. So they either die or they move to deeper ocean water away from those coastal areas. So because of this, a couple things happen. We have a disruption in tourism, and that might not sound like a big deal, but it is a big deal to those who depend on that for a living in the Gulf of Mexico. We also have a fairly large impact on the fishing and shrimping industry in the Gulf of Mexico. I actually wrote a term paper on the effects to the local economies in the Gulf of Mexico, and it does have a large impact on the fishing economy, as well as can have a large impact on the tourism economy as well. So why else should we care about keeping nitrogen fertilizer or nitrates out of waterways? Well, if babies or other susceptible humans ingest water that's high in nitrates, it can actually cause a symptom called blue baby syndrome. So I'm not a medical doctor, but whenever high nitrates get ingested, for some reason it is difficult for the blood to carry normal oxygen levels, and babies are particularly susceptible to it. Now, luckily, blue baby syndrome is very rare in urban or suburban or cities. And it's somewhat rare in rural areas, but more common because rural drinking water or well water is often not treated for high nitrates. So even though it's pretty rare, it's still a concern because in urban areas, we have to spend lots of money treating the water to make sure it is not high in nitrates and does not cause things like blue baby syndrome. So that's nitrate. What about phosphate? What happens when we get too much dissolved phosphorus in water? Well, dissolved phosphorus is a particularly significant problem in fresh water. So in salt water, nitrogen is the most limiting nutrient, but in fresh water, phosphorus tends to be the most limiting nutrient. So we have the same socioeconomic issues whenever freshwater bodies get contaminated with dissolved phosphate. And this is what happens typically in the summertime in Lake Erie and Lake St. Clair. We often have a large algal bloom, which is especially difficult on tourism. It affects wildlife and fishing in those areas, and it also affects their drinking water supply. I believe Toledo and Cleveland get their drinking water from Lake Erie, and it's a particular problem for the Toledo drinking water from my understanding. So what we've learned so far is that there are some consequences to not keeping nitrogen and phosphorus fertilizers out of waterways. And the bonus is that when we do keep nitrate, nitrogen, and dissolved phosphorus out of waterways, farmers also make more money because nutrients not in waterways are contributing to crop uptake and crop yield. So it's kind of like reading your birthday card and pretending you don't see the money. So keeping nutrients out of water bodies also contributes to farmer profitability. So there's two very good reasons why we should be focused on environmental stewardship, particularly maintaining healthy and clean waterways. So what are some factors that can help us keep nitrate, nitrogen out of Scott County water systems? Well, nitrogen timing. So for example, moving from fall applied nitrogen applications to spring or in-season nitrogen applications. And if there are farmers in the audience, they know well what I'm talking about. It's all about nitrogen timing. Applying the nutrients closer to when the crop's growing So that way it's less susceptible to loss and more accessible to crop uptake. So rate, it's not profitable for farmers to use rates higher than they need to maximize their return on investment. So nitrogen rate response in corn, so it's a quadratic plateau or a quadratic response function. So as you apply more nitrogen, you get diminishing returns on your investment. We'll talk about that in a little while. And whatever nitrogen doesn't get taken up by the crop and used to produce yield can be lost over the wintertime. We're not going to talk a lot about inhibitors, but keeping nitrogen in the ammonium form, which is positively charged and sticks to the soil, is a positive thing. And there are some legitimate inhibitors out there that can inhibit the nitrification process that keeps it in the ammonium form. Again, I'm not going to talk a lot about this, but I want to preface legitimate inhibitors. There's some inhibitors out there that don't do as advertised and claimed. And if you have questions, that would be a great question for the end. And again, just because of time, I don't get into that in detail. And finally, cover crops. Cover crops, it's a living, growing plant that's planted after the cash crop. It grows throughout the winter and basically scavenges any extra nitrogen left from the season or being mineralized from the soil. And that also can contribute to keeping nitrate nitrogen out of Scott County water systems. So I'm not going to spend any time on this, but this is a figure from the Iowa Nutrient Reduction Strategy. And it basically shows all those management factors that I just discussed and the reduction, the estimated reduction in nitrate nitrogen that you could expect from implementing these practices. So now we're going to go into a little bit more detail on each of those nitrogen, each of those practices to limit nitrate in Scott County waterways. So we talked about not applying fall anhydrous ammonia. Well, this is a 3-year Iowa State study where they looked at comparing fall applied anhydrous ammonia to pre-plant or in-season nitrogen sources. Okay, so all the nitrogen sources here were anhydrous ammonia. The nitrogen was either applied in the fall as a pre-plant application or as a side dress application. And I'm going to point out a couple things. So here's nitrogen rate on the x-axis and yield on the y-axis. All right, so with the pre-plant or side dress applications, we generally see the same yield with nitrogen rate. All right, but we notice that with the fall anhydrous application, we have lower yields at every individual N rate than we had with spring or in-season applications. Not only that, not only do we have 6% lower yields on average, it also took 54 more pounds of nitrogen to maximize that 6% lower yield. So it took 200 pounds of nitrogen or more to maximize yield when fall applied, but it only took somewhere around 150 pounds of nitrogen to maximize yield, a higher yield with spring or in-season N applications. So again, this was a study done near Ames over 3 years, and we found higher yields by applying 54 less pounds of nitrogen, which basically would have gave us about a $47 per acre profit. So here's an example of a management practice that's good for the farmer and good for the environment. So I just wanted to point out a study that shows this extremely well. So what about nitrogen rate? We talk that if you apply a nitrogen rate that's higher than needed to maximize economic return, that extra nitrogen can be lost over the wintertime to tile lines and overland flow and contribute to nitrate nitrogen in waterways. Well, I'm not going to get into the extreme details here, but if you're a farmer and you want to know what nitrogen rate should I use for my corn, you should basically go to the Iowa State. Well, you should basically Google the maximum return to nitrogen calculator. So we know that to decide what the best economic nitrogen rate is, it's an economic function. It depends on, what's the price you're going to receive for your corn, what's the price you paid for your nitrogen, and that basically dictates the amount of nitrogen you should apply to your corn crop. And I'll give you an example here. Okay, so if you're a farmer, you probably know that nitrogen in early January went from about $200 a ton. This would be UAN, for example, to now it's approaching $350 a ton, I believe. So we've had an extremely aggressive price increase in the cost of nitrogen fertilizer, which would cause you to change your nitrogen rate, because yield is a function of the cost of nitrogen, and economic yield is a function of the cost of nitrogen and the price you're going to get for your corn. So with this calculator, you can plug in the cost of your nitrogen, what you believe you're going to pay for what you believe you're going to get paid for your corn. So here will be the fertilizer cost. As you apply more fertilizer, it costs you more. As you apply more fertilizer, you also get a higher yield to a point. And this orange line is your net return. So it's the difference between the fertilizer in cost and the yield you get from that fertilizer. So in other words, this tells you that for a corn-soybean rotation in eastern Iowa, I should be applying somewhere between 155 and 184 pounds of nitrogen at a 208-ton nitrogen cost, if I believe I'm going to get $5.20 for my corn. Wow. When I punched this in, I bet I meant to put 420, but I did put 520. So bottom line is you can change the corn price as well as the nitrogen price, and it's going to give you a range in which you're going to maximize your yield. So you can do that for your higher nitrogen price, and now it gives you a range between 145 and 170 here. So your nitrogen rate was a little bit lower because your nitrogen price was a little bit higher. So that's part of the nutrient. This is the recommendation from the nutrient reduction strategy put out by the state of Iowa and Iowa State. So this is how you should decide how much nitrogen you apply to your corn. If you have any questions about that in more detail, we can talk about that at the end as well, or now if you'd like. So what about nitrogen timing? We talked about fall or spring applied nitrogen, but what about, if you're putting on fall manure or side dressing or spring anhydrous or spring UAN? How do these different timings in the spring even affect the nitrogen rate that maximized economic return? Well, this is actually an Iowa Soybean Association study. And in this study, there's 479 farmers' fields where they actually did nitrogen rate response curves in almost 500 fields from 2006 to 2013. So this should give us a really good idea of, if we side dress our corn versus applying it all in the spring, how much can we reduce our N rate? Or if we apply it all in the fall, how much more N would we have to use to maximize economic yield if we apply it in the fall? Okay, so we've got corn, soybean, and corn continuous corn rotation here. Notice that spring anhydrous and spring UAN, approximately about 150 pounds of nitrogen or 155 pounds of nitrogen it took to maximize yield. And with corn soybean rotation, it also required about 150 pounds of nitrogen side dressed. So we don't see a big ability to reduce our nitrogen rate just because we side dress in a corn soybean rotation. But do notice that if you're putting on fall manure or fall anhydrous ammonia, now it does require a larger N rate to maximize yield in this rotation. When you go to the continuous corn rotation, however, now if you side dress your continuous corn, you can apply a little less nitrogen because you're more efficient with it as a side dress application. So 165 versus about 180 with spring anhydrous or UAN. And here, look again, now with fall manure, it took 230 pounds of nitrogen to maximize yield, or 200 as fall anhydrous ammonia application. So I just want to point out, particularly in the continuous corn rotation, as you apply that nitrogen closer to the time of plant uptake, you can actually reduce your total N rate and become more efficient with that nitrogen that you do apply. So what about crop rotation? You've seen there in the nitrogen reduction strategy numbers there that actually growing corn in a rotation with soybean versus a continuous corn actually reduced nitrate nitrogen concentrations in tile line water. And this figure shows you the same thing. So here's the nitrogen rate that was applied to either a corn-soybean rotation or the nitrate in tile line water in a continuous corn rotation. So by just growing corn in a rotation with soybean, you can reduce the overall nitrogen load found in tile lines. Presumably because you're using a lower overall nitrogen rate in those situations. Corn is also less efficient at taking up nitrogen when grown after corn. Was there a question I heard?
Yeah. So do you apply nitrogen by soil type? Do you apply by grid sampling to vary the rate applied?
Is that a question by the audience?
Yes.
The place that I would start, you ask a great question, and that could be a very long answer. I think the place you start as a farmer, you don't necessarily use soil type, you don't necessarily use grid samples or any kind of management zones. You start by entering the number one, when you go to this maximum return to nitrogen rate calculator, it's going to ask you what part of the state of Iowa you're in, okay? So it's automatically taking into some soil factor accounts based on the questions that it asks you in the beginning. So if you're in Southeast Iowa, it's going to give you a different recommendation than if you're in Northeast Iowa or Northwest Iowa, for example. So it's taking into account general soil type differences in the first place. So after that, then you need to enter the price that you believe you're going to get for your corn and the price that you paid for your nitrogen, because again, it's an economic function. It's an economic question. So I would use this tool as a place to start. Okay. Now keep in mind, consider this as an average soil for the state of Iowa. But if you have a highly productive soil that's got higher organic matter than most of the soils in your region, you could expect to be able to apply a little less nitrogen than this calls for. On the other hand, if you have a very poorly drained field, more poorly drained than the average field in your part of Iowa, you're going to have to apply more nitrogen to maximize economic return. If you have a sandy field where you have lots of nitrogen leaching, you're going to have to apply more than this. So it really depends a lot on your specific environment, and you can use management zones to help change how much you change the N rate from these recommendations. But this is a good place to start. And if I knew more about your specific operation, I could absolutely help you decide, what's the most appropriate rate, a way of going about, okay, 157 pounds is what the maximum return to nitrogen rate calculator says I should apply in my region of Iowa. But how do I decide if that's enough in my specific field? I could help you with that if I knew more about your cropping system, and I would advise you to work with your local agronomist or a trusted advisor to help you decide, should I apply more or less than what the maximum return to nitrogen rate calculator recommends? So I know that was kind of a generic answer, but it's the truth. I just have to know more in order to answer that question extremely well. So what about cover crops? Cover crops, put simply, if you have a living crop out there that has a root system that's taking up nitrogen after your corn crop, it's helping to scavenge any leftover nitrate or ammonium. And in the state of Iowa, we see that there's about a 27% reduction in nitrate in tile lines when a cover crop is grown. Pretty much every single year here in this Iowa State study, nitrate nitrogen concentrations were reduced when a cover crop was grown compared to no cover crop. Cover crops also help sequester atmospheric carbon, which we will talk about at the very end. So what about phosphorus management? We talked through nitrogen management. We can adjust our nitrogen timing. We can adjust our nitrogen rate. We can consider growing corn in rotation with a soybean, and we can consider using legitimate nitrification inhibitors. All those things, and using cover crops, and all those things are going to contribute to making sure that excess nitrate doesn't end up in Scott County waters. So what about phosphorus? Yeah, here's kind of the few key points I wanted to go through. Don't let the concentration of phosphorus become excessive in your soil, and we'll go through that in a lot more detail. And to do that, you're going to think about using manure and/or fertilizer management, specifically likely variable rate fertilizer technology. Another thing you can do to greatly reduce the potential of losing phosphorus is placing it, using a source or placing it below the soil surface. Anytime you slow erosion, specifically sheet erosion, you reduce phosphorus loss into water bodies, because phosphorus is also oftentimes very tightly bound to the soil itself. So if you're losing soil, you're losing phosphorus, and you can achieve that through reduced or no tillage. You can also reduce rates and use placement, like I talked about earlier, as well as inhibitors to maximize your fertilizer efficiency. So in other words, can you use placement and protectants to maximize fertilizer efficiency? We're not going to get into that, but just like nitrogen, there are some legitimate inhibitors out there that would allow you to do that. And if you have questions about those legitimate type products, I'm also happy to answer those at the end. And then again, cover crops. If cover crops can reduce erosion, there's also a good chance that they can reduce the amount of phosphorus that reaches fresh water bodies here in Scott County. So I mentioned, reducing or not allowing or reducing high concentrations of phosphorus in the soil. So just like nitrogen, we would have lower phosphorus levels on this side of the x-axis and higher concentrations of phosphorus on this side of the x-axis. And then we have plant yield on the y-axis here. So to a point, as the soil test concentration increases, it also increases yields. But somewhere here around the 20 to 50 part per million of phosphorus, we generally see yields plateau, and definitely not above 75 part per million of phosphorus in the soil do we often see yield increases. Okay, so there really is no reason to keep your soil test levels above 50 or so part per million of phosphorus. We also see as we increase the concentration in the soil, we have a higher potential for phosphorus runoff with soil itself. So if we have a high concentration of phosphorus in the soil and we happen to have erosion, clearly that would contribute to contamination of waterways. Now this is actual surface runoff of water, of soil moving into water bodies. Something else that can happen with phosphorus that we don't often think of is that when it becomes concentrated enough, phosphorus can actually leach as dissolved phosphorus. So when we get up here around the 200 part per million of phosphorus, we actually start to have phosphate leaching. So you definitely don't want to be above 200 part per million, and it's probably not a great idea to be above about 100 to 75 to 100 part per million. So put very simply, we all, I think if you're a farmer, you know what variable rate fertilizer technology is. Turn the machine off if you have soil test levels that are above 200 part per million for sure, because we do not want leaching of phosphate as dissolved phosphorus. And it's also not necessary to apply phosphorus in areas where phosphorus levels are above about 50 to 75 part per million. You can just go ahead and shut the machine off at that point, because you're probably not, in most cases, going to get a yield increase to adding more phosphorus fertilizer in those cases. So here's what I'm talking about. This is a grid sampled map actually on 1 acre grids of a farmer's field that we work with. These areas in dark green here, all these areas are above concentration what we would expect a response. You don't have to overcomplicate variable rate fertilizer. The most important thing you do is you shut the machine off when you enter these green areas. Okay, now I'm going to put a little plug in for the company that I work for because it's important to this variable rate fertilizer concept here. And if you don't know Liqui-Grow or you don't know Rock River Grain and Lumber, at Liqui-Grow, all of our phosphorus and potassium fertilizer is applied via a liquid suspension fertilizer material. And I probably don't have time to get into great detail what that means, but essentially it's a fluid fertilizer that has a similar cost to MAP, DAP, and conventional dry potassium chloride. So we manufacture a fluid suspension fertilizer that has a cost that's comparable to traditional dry fertilizer. Well, that allows us to apply these fluid fertilizers in bands as well as extremely uniformly. And I'm going to talk a little bit about the inability of dry fertilizer machines to apply nutrients uniformly. So I'm going to show you an Iowa State presentation here where they looked at the ability of a dry fertilizer spreader to apply nutrients uniformly. And this machine was calibrated by the Iowa State engineers on a 60-foot swath width. So this here would be when they applied 54 pounds of fertilizer material and as DAP, that would be 24.8 pounds of phosphorus. The black lines here are the edge of the calibration swath, all right? So anything out here, don't pay attention to because that will be caught on the next swath, on the next pass, okay? But notice how we go from low rates. You can see here, this is the target rate. So at a 24.8 pound of P application rate, that machine does a very good job. But notice as we go to 49.6 pounds was the target application rate, we start to get a poorer spread pattern. And when we get to 99 pounds of P, we get an even poorer spread pattern. And in this case, we would have about 24 fewer pounds of P applied in the middle 30 feet of this swath as we would on the outer total 30 feet of this swath. And that alone can affect crop yield, all right? Here's a Ohio State publication with a wider swath, so now we go from 60 to 100-foot swath. And in this case, we had 50 fewer pounds of P applied in the middle 50 feet of this dry fertilizer applicator here. Now, this becomes a problem because we talked about when we get to higher rates, what happens, the uniformity gets poorer. Well, that means in an area in green that we don't need any phosphorus, we're applying low rates, and it's doing a very good job, or no rate, right, because it's doing a very good job. But when we get into the higher, the areas with lower fertility levels where we need lots of phosphorus, we get a very poor rate. So where we really need the nutrients to increase yield, we're actually applying it poorly, and we would see yield reductions to doing so, okay? And now I'm going to talk to you very briefly about a liquid fertilizer study, all right? So while we're on this subject, I'm going to tell you my only claim to fame is that my advisor at Oklahoma State was this guy back here by the name of Dr. Randy Taylor. And Dr. Randy Taylor was actually Garth Brooks' roommate at Oklahoma State. So Dr. Taylor actually wrote the song "Way Too Young to Be This Damn Old." That's my only claim to fame, is that my one of my advisors at Oklahoma State was Garth Brooks' roommate. So he actually published this study I'm about to show you here. So before I show you that study, I think it's important to come back to that Iowa State study real quick. So in this study, not only did they measure the ability of that machine to apply nutrients across the swath, they also measured what is the average variation in fertilizer rate from pass to pass caught in each one of these bins, okay? And so you can see in the furthest bin away from the center of the machine, there's as much as 50% variation from pass to pass in the amount of fertilizer caught in that bin. In the middle, it was good. You know, we had less than 10% variation. But here on the outer swath, on part of the outer swath on the right-hand side, now we're up to 35% variation. So average across that machine, you're only guaranteed to get within 33% of the rate that machine was calibrated to apply. Compare that to a liquid fertilizer machine. This is the variation from nozzle to nozzle in that Oklahoma State study I mentioned. Here the nozzles vary by 3.4%. So the reason I talk to you about this is that variable rate is a very important part of the equation to reducing phosphorus loading in streams. And if you're going to do it, you want to be able to do it accurately in a way that's going to maintain yields for the farmer. And fluid fertilizer is extremely, you can pump it and meter it with rate controllers and flow meters. And it can be applied very accurately. Here's an example from another study where they actually measured the as applied rate versus actually caught rate in the field. And if the as applied rate was identical to the actual rate, you would see all these dots line up on this one-to-one line, and you don't, right? So sometimes when the as applied rate was supposed to be 400 pounds, you're actually catching 325 or 615 pounds of fertilizer per acre. So this basically just goes to show you that applying nutrients where they need to be is a part of nutrient stewardship, and dry fertilizer machines are not very capable of doing that. This would be a liquid suspension fertilizer machine that was being tested down in Texas at the USDA ARS facility down there. Here's the desired rate in liters per hectare and the actual rate. So these fluid fertilizer machines, extremely capable of putting nutrients where you want nutrients, and that's important to maintaining levels in the soil that are not conducive to phosphate leaching or runoff events that's going to contaminate waterways. Okay, what about erosion? We talked about erosion. Well, cover crops and reduced tillage are both ways to reduce sheet erosion and therefore reduce phosphorus loss to waterways. So what happens when it rains out? Well, a raindrop is like a little bomb to a soil pad or the soil surface, right? So it may not hurt too bad when it hits you, but think about some little soil pads. When a raindrop hits an exposed soil, it busts apart those pads and it sends very tiny clay and silt particles careening through the air. And then when the surface soil gets saturated, it's easy for those little bitty soil particles that are no longer connected to other particles and pads to be easily washed away as sheet erosion. And what did we say? We said where we have phosphorus connected to soil, when we physically lose soil, that's when we physically lose phosphorus from the field. So, you know, if you have residue laying over the bare soil, what would happen? The residue would protect the soil from these raindrop impacts. The same would be true with a cover crop. If you have a cover crop growing over the soil itself, the cover crops would basically intercept the force being applied by the raindrops and reduce this rain splash impact. And if you have the combination of the two, it does a very good job. So cover crops and leaving residue on the soil surface reduce sheet erosion and reduce phosphorus runoff into waterways. What about phosphorus source and placement? So here's a really recent study that was again done by the USDA ARS out of Texas again, believe it or not. So here they wanted to look at different fertilizer sources. All right, so we've got monoammonium phosphate, diammonium phosphate, so MAP and DAP, the old triple superphosphate, O46O, polyphosphate, which is a fluid fertilizer, single superphosphate, rock phosphate, poultry litter. So these were all surface broadcast applied. And then down here we have MAP, polyphosphate, and poultry litter that was subsurface banded. Only 1 centimeter deep, I might add, okay? And let's just look at the relative loss for all these different broadcast applied fertilizers on the soil surface. Basically, notice that for MAP, DAP, and triple superphosphate, we had anywhere between 16.5 to 19% loss, relative phosphorus loss when you broadcast applied those phosphorus fertilizers to the soil surface. But look at ammonium polyphosphate, which is a fluid fertilizer, which happens to be the fluid fertilizer that we apply in our liquid suspension. There was less than 1% loss with the fluid fertilizer, and I'll explain to you why that is. Okay. Also look at when you banded or you subsurface injected, only 1 centimeter, might I add, the MAP, polyphosphate, or the poultry litter. In this case, you had all between 1% loss when you put that phosphorus fertilizer just 1 centimeter under the soil surface. And a centimeter is not very far. And this is because when you have rainfall events, putting that phosphorus just below the soil surface protects that phosphorus from sheet erosion, like we just talked about, okay? So anytime you ban any of these sources of phosphorus, you protect and reduce that phosphorus from sheet erosion. But look at the polyphosphate. We applied that to the soil surface, and we still had a much reduced chance of that fertilizer source being washed away via sheet erosion. And we'll talk about why that is here real quick, okay? I think it's important to understand that polyphosphates, the MAP, DAP, and O46Os, or the triple superphosphate, it is an orthophosphate. It's a single molecule orthophosphate ion. It's extremely easy to associate or be temporarily tied up by iron, aluminum, calcium, organic matter. It's a very simple molecule that's complexed very easily. Polyphosphates, on the other hand, are multi-chain orthophosphates. They can be simply two polyphosphate or two orthophosphate chains hooked together, or they can make much more complex chains like a hexaphosphate chain. That's many orthophosphate chains hooked together. And this basically happens in the phosphorus manufacturing, the ammonium polyphosphate manufacturing process. But because these are more complex molecules, they don't absorb right away to soil colloids or iron or aluminum or calcium or organic matter. It takes more time for these polyphosphate ions to break down before they attach to those compounds in the soil. And that time allows these more complex ions to slowly move down just under the soil surface where they're more protected from erosion. And not only did you see that in that study by the USDA-ARS, you can also see this in a study that was done in the early 2000s by the USDA-ARS, actually in Ames, Iowa, by a scientist named John Kovar. So he applied ammonium polyphosphate in a surface band that was 2 inches from a corn plant, and he measured how far down that ammonium polyphosphate moved when applied in a concentrated band. And he found that a great majority of that polyphosphate actually moved down as deep as 3.5 inches. So this red line is 3.5 inches, and he measured this 43 days after the ammonium polyphosphate application. So in general, we see a little bit of downward movement when we broadcast apply it because the polyphosphate does not get tied up in the very top surface soil. It's allowed to move down a little bit, but when you band apply it on the surface soil, now it's more concentrated and moves down even further. So the source alone can actually protect phosphorus from sheet erosion into waterways. Just a very brief minute on practices that can sequester carbon. So luckily enough, practices that reduce nutrient loss in the waterways also sequester carbon. So this is a meta-analysis of factors that can help sequester carbon in the soil. So cover crops, nutrient type, and tillage. So specifically, cover crops and tillage are 2 factors that can contribute to building soil organic carbon. And if we're taking carbon dioxide out of the atmosphere and putting it in the soil via plants, we're actually building soil organic carbon. And if you don't know, you should start reading and listening to some of the popular press out of the ag economy at the moment, because there are many companies that are actually now willing to pay farmers for sequestering carbon in their soil. So not only now, can farmers, one of my beefs with conservation has always been that, with cover crops, for example, that costs farmers money. Yes, there's some government programs that farmers can get to help recover that cost, but it costs farmers money and it increases risk for farmers. But now with these carbon initiatives, farmers can actually get paid for storing carbon in the soil, which actually makes it a little easier for a farmer to rationalize. And there's two programs that our company, Twin State Liqui-Grow, has partnered with. There's a group called Ag Outcomes, and there are watershed-specific payments in all these counties in green, which would include Scott and Muscatine County. You can get $20 to $40 per acre for implementing new conservation practices if you enroll in this Ag Outcomes program. There's also another program that we just recently partnered with called TruTerra, and it's actually solely focused on increasing soil carbon. And a farmer can get up to $5 to $20 per acre per year for new practices implemented within the last 5 years. So TruTerra is a recent look-back payment, and Ag Outcomes is if you implement new practices going forward, you can get paid via the Ag Outcomes. So we actually are having an informational meeting on March 16th at the West Liberty, Iowa Community Center. It starts at 9 a.m. It ends at 11:30, and we're going to have experts there from Ag Outcomes, TruTerra, as well as one of the owners of our company is going to speak about the future of carbon markets, and I'm going to speak about some of the agronomic considerations and things we want to consider if we're going to try to attempt cover crops for the first time or on large acreages. I think there's a potential profit stream here for farmers, but we can't forget that cover crops complicate the crop rotation, and if we're not careful, we can lose $20 to $40 per acre pretty quickly if we try to implement a no-tillage or cover crops on the entire operation without thinking about some of the things that we may need to adjust before we do that. So with that, we'll start the question and answer period. We have a few minutes. I don't know how tight we are on time. I know we're supposed to be done by 1 o'clock, but I'm happy to answer questions log into that. If you're a CCA and you have the CCA app, you can take a picture of this QRL code here, which will get you credit for listening to me ramble for an hour. If you have further questions, you can email me at the email address there on the screen. You can also call our office and ask to be connected to my office phone. And if I'm not here, leave me a message that's connected to my cell phone, and I will be sure to return your call. Appreciate your time, attention, and thanks for, I thank Scott County Watershed Partners for inviting me to talk today.
Thanks, Jake. And we will email this information about the CCA credits to everyone who attended today too, in case you can't write it down right now. If you have any questions, please type them in the chat box and we will forward those to Jake. Jake, you can stay on as long as you're available, and I can stay on too if we have more questions.
Casey, if anybody's interested, I can also send this you can send this presentation out if you'd like. If they have, if they want to look at some of the figures I went through. I know I went through some of those things fairly rapidly, but happy to share this if folks want it.
Okay, great. And yes, we will be posting this on Partners of Scott County Watershed's YouTube as well. So it'll be available there for anyone to view on their own time. I will also mention, while we're waiting to see if questions come in, thanks to the generosity of the Iowa Corn Growers Association, Partners has an extra supply of nitrate and nitrite test strips that we are going to offer for free to citizens and businesses of Scott County. We can do this in two ways. A partner's representative can come to your property and conduct a one-time free water quality assessment using these strips and other water quality parameters, along with showing you how to use this equipment if you'd like to purchase your own and interpret the results. Another option is that we can mail you up to 8 nitrate test strips for you to use on your own, and then we will include instructions in that mailing as well and be available to answer any questions you have on interpreting those results. So I'm going to post this information on Partners of Scott County Watershed's website, and if you have other questions about it, you can also email me at info@partnersofscottcountywatersheds.org. Once again, I will wait 1 minute to see if we get any more questions in the chat. I thank everyone for attending today. Our next educational forum will be on Tuesday, March 16th from noon to 1 via Zoom, and you can find information on how to register for that through our website as well as our social media pages.
If there's any farmers on the line, I'd be interested if they've heard about these carbon markets. And if there's no farmers on the line, I'd be interested to hear if anyone else has heard about these carbon markets and what their thoughts are on those. I guess everybody's shy today, Casey.
I guess so. All right, well, thank you so much, Jake, for your presentation. And if anyone wants to watch this again, stay tuned to YouTube, and we will post this information on our website, and we will hopefully see you at the forum on Tuesday. Thanks so much, Jake.
All right, thank you. Bye-bye.